Hello, ladies and gentlemen. It's Algebra 2 review time. We're going to see if we can get the second quarter done here in about 20 minutes. So first thing, just reviewing some basic polynomials. When you're adding, these parentheses don't matter. You're just combining like terms. 8x to the fourth minus 8x to the fourth, those cancel out. -2 and +8, that makes 6x cubed, and 5 plus 1 is 6. So 6x cubed plus 6. The only thing that's different when you subtract is you need to make sure you subtract everything in this quantity. So now it's +7 and minus 6b to the third. You got to distribute the negative. Now I got, let's see, 7 and -2 make 5b to the fourths. 7 and -6 make 1b to the third. And I think I just have -2 and +7, which makes 5. So 5b to the fourth plus b to the third. Plus 5, you don't really have to write the 1 if you don't want to, so that's fine. Next one, we're multiplying. So when you're multiplying, you need to make sure you distribute. So I'm going to multiply this times everything, and then that times everything in the second term. So that's a total of 6 multiplications. 2 times 4 is 8. A times a squared is a cubed. 6 times 4 is 24. A times a is a squared. 4 times 7 is 28a. Minus 6 times 2 is 12a squared. -6 and +6 make -36, and -6 and 7 make -42. Combine my terms. I have 8a cubes. I have 24 minus 12, which makes 12a squareds. I have 28 minus 36, that's -8a's, and then I still have -42. So that's your answer. Completely factor. So on a multiple choice test, obviously you can work backwards, but this is a formula. It's a, b, a squared, ab, b squared. And then the signs are SOAP. So if this is positive, the same, opposite, always positive. What's the cube root of x cubed? That'd be x. The cube root of 125 is 5. So x plus 5. If you take that x and you square it, now you have x squared. If you multiply these two things together, you get 5x, and 5 squared is 25. So that is a sum of cubes. You just have to remember the formula. Here there are 4 terms. It looks like there's a big GCF. So first let's do the GCF. They're all multiples of 2. X cubed minus 4x squared minus 3x plus 8. So first factor out the GCF. Now since you have 4 terms, you're factoring by grouping. So you find the GCF of the first half, that's x squared. X minus 4, and then the GCF of the right side is a 3, but bring down the negative. X minus, wait a minute. That's not right. What did I do wrong? Oh, I see what I did wrong. Right here. That's not 8. 2 times 12. There we go. 2 times 12 is 24. Duh. Now, anyway, carry on. That's going to make more sense. So when you bring out a -3, -3x times -4 is +12. Okay, what's supposed to happen if you can factor by grouping is these are the same. So you can tell I ran into a mistake there. X minus 4 and the other factors, x squared minus 3. Don't forget the 2 out front. This sometimes could be factored more. Like if that was a 9, that'd be dots, x plus 3x minus 3. But since 3 is not a perfect square, you are finished. That's all we're going to do for now. Last one, again, look for big GCF. These are both multiples of 3, and now we have 16x squared minus 9. But again, this is one where you got to look, hey, wait, those are both perfect squares. The square root of 16x squared is 4x. The square root of 9 is 3, so 4x plus 3, 4x minus 3, and don't forget that 3 out front. That is completely factored. You should have no GCFs in here. If you have a GCF, you're not completely factored. Synthetic division. So synthetic division means we're going to plug in what would maybe be 0. If that's a factor, let's try -3. And now I'm going to write the coefficients here. 8, 25, 12, and 26. The way this works is you bring down the 8, and now we're going to multiply and add, multiply and add, multiply and add. So let's multiply. 3 times 8 is 24, and it's negative. Add. 1. Multiply, add. Multiply, add. So since it's not 0, I know that this is not actually a factor, but I can write my answer. We've done it a couple different ways. One way is this is now a quadratic, so let's write 8x squared plus x plus 9. And then you can write the remainder as 1 over x plus 3. That's one way to write your answer. Another way, sometimes we write, oh, Bell, quotient 8x squared plus x plus 9 times divisor x plus 3 plus the remainder. That's another way we've written our answer, quotient times divisor plus remainder. This way you can expand it and check it. This is more of a division answer. So this is probably what you'll see in black for your answer on the test. Analyze. So first thing you're going to want to do is list possible rational zeros. So 1 and 2. You list the factors of each of these, and then you write these as numerators. So 1 over 1, 1 over 2, plus or minus 1 over 1, plus or minus 1 over 2, 1 over 1, 1 over 2. Same thing, 2 over 1, 2 over 2, 2 over 1, 2 over 2. 2 over 2 is actually a repeat. That's 1 over 1, so you don't really need to list that again. Degree. So to find the degree, you look at the highest degree anywhere in there. That would be degree 3. This is degree 3, which means it has at most one less than that turning points. Degree 3, you could have at most 2 turning points. It's going to look something kind of like that. That's 1, 2 turning points. Find all zeros. Find all zeros. Well, the first thing I'm going to do is graph it, and that might be all I need to do. So I'm going to graph this using either my calculator or Desmos. 2x cubed plus 5x squared plus 5x minus 8. Let's see if I can remember that. 2x cubed plus, I got it on paper here, plus 5x squared plus x minus 2. So wait a minute, I can see all my zeros right there. It looks like they are at -2, -1, and 1/2. So I don't even really need to solve anything. They're all real and they're all rational. So -2, -1, and 0.5. X equals -2, x equals -1, x equals 0.5. I'll write that as a fraction. There's no imaginary zeros, so I don't really need to do any more work. I can just look at the graph. Cool. Sketch. So when I say sketch, you could obviously type these in your calculator, but you don't need to. This is positive and odd. So positive odd means it's going to look like that. It is a leading coefficient of 3 and it has a degree of 5. So you need to be able to read this notation. As x goes to infinity, that means as you go to the right. As you go to the right, this function goes up, so it goes up to positive infinity. X goes to negative infinity is going left, y is going down, so we say negative infinity. This guy has a negative leading coefficient and it is even degree, so that means it makes like an M, which means y is going down on both ends, so negative infinity, negative infinity. This guy is positive and even, so it's going to make like a W, means it's going up on both ends. This is positive 3 and it's even 6. Here's negative odd like that. That's -2 and it's degree 3, -2, degree 3. So it's as you go to the right, as x goes to infinity, as you go to the right, it goes down. And as you go to the left, it goes up. So that's end behavior. We're just describing it using what we know. You could graph the actual functions if you want, but I can promise you the end behavior is all we're looking at here, and it's going to follow this pattern. All right, let's see what else we got. Simplifying some exponents. Okay, so the first thing we'll do is I like to move all these negative exponents to the bottom. Negative exponents from the wrong side of the fraction bar, and then I can combine them. 2 and 1 make 3 v's in the denominator. This is negative. Remember, n to the 0 is 1, so that's -1, and it's in the denominator, so you got to be kind of careful here. This could be tricky. Let's see. This is -1, which is going to go to the -2nd power, n to the -2nd power, and m to the -6th power. So everything's going to the bottom. So now it's 1 over, but now this is actually really tricky because negative times a negative, when it gets squared, is going to be a +1. And then this will be n squared, and this will be m to the 6th. It's actually +1 in the denominator. Interesting. Okay. Here we're going to do 2 cubed x to the -6th, y to the 3rd, 6 cubed x to the 12th, y to the -6th. I'm multiplying all the exponents by 3. Now I'll simplify what I can. So I like to do this horizontally. 2 cubed is 8, 6 cubed is 216. X to the 6th, these are going to go to the bottom, and there's already 12 of them down there, so now that's x to the 18th in the bottom. And these are going to the top, there's already 3 of them up there, so y to the 9th. So 8y to the 9th over 216, x to the 18th. Simplify roots. So the first thing I like to do is factor. That's 81 times 2. 3, 9, 27, 81, 2, x, 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 y, y, y. Pardon the bell. This is a square root, so we're looking for groups of 2, group 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 of 2. All that can come out. 3 can come out, another 3 can come out. That makes 9. X can come out, another x comes out. That's x squared. Y comes out. What's trapped? 2y. Cool. Same game with a cube root. 27 times 2, x, 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 y, 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 y. We're looking for sets of 3 though, because it's a cube root. So set of 3, set of 3, set of 3. 3xy comes out. What's still trapped? 2y squared. Okay. You might be able to do that in your head if you know perfect cubes, but if not, completely factor it. Let's try that again. 32 is 2, 4, 8, 16, 32. 50 is 25 times 2. So this is 4 radical 2 plus 5 radical 2. Now these have the same radicand, so they are like terms. If you have 4 radical 2's and you had 5 radical 2's, you have 9 radical 2's. 3 radical 5 plus 5 times, that's 5 times, that's 25 times 3. So 3 radical 5 plus 5, and you already have 5 of them, so 25 radical 3's. Multiply. 5 times 5 is 25. So here, evaluate these. You can just type in your calculator if you got a calculator, but we can do it without it. This is saying the square root of 16, the square root of 16 is 4. This is saying the cube root of negative 32, and then cube it. The cube root of negative 32 is negative 2. I'm sorry, the fifth root. I don't know why I said cube root. Fifth root. And then you're going to cube it. Negative times a negative times a negative is negative. 2 cubed is 8. Okay. Here, take the cube root of 27. That's 3, and then square it. You get 9. Just got to know that the denominator is the root, and the numerator is the power. So do the root and then the power. Usually is easier. Doesn't really matter, but it's usually easier. Let's see what else we got. Oh, okay. Solving now with exponents. So finding inverses, you got to flip x and y. So this is x. This is the cube root of y plus 2 minus 1. Let's move this over here. Now to undo cube rooting, we're going to cube both sides. So I have x plus 1 cubed equals, now I have the radicand y plus 2. I need more space. Last thing I'm going to do is subtract 2. So x plus 1 cubed minus 2. But instead of y, I'm going to say f inverse equals. That's how your answer is normally going to look. F inverse. That becomes y now I know I've got the inverse. Let's do the same thing. X equals 6. Y minus 5 to the 5th plus 2. First, isolate the exponent. Get this by itself. So subtract 2, x minus 2. Then divide by 6. You cannot take the fifth root yet. Divide by 6. So x minus 2 over 6 equals y minus 5 to the 5th. Now I can undo the power by taking the fifth root of both sides, which is just messy. The fifth root of x minus 2 over 6 equals, you know what? If it equals y minus 5, I'm going to add 5 to both sides, and I'll write it as f inverse x. So the last thing is you move the 5 over. Kind of messy, but that's it. Now I'm going to do some composite functions. So to do composite functions, I'm going to add, this says f plus g, so you just add them up. 3x minus 1 plus x squared plus 1. Got any like terms? X squared plus 3x, those cancel out. F minus x, 3x minus 1 minus x squared plus 1. Easy way to miss the problem is to leave it alone. You need to make sure you distribute the negative. 3x minus 1 minus x squared minus 1. So be very careful here because you have to distribute the negative. Now it's negative x squared plus 3x minus 2 when you put it in standard form. F of g of x. So to find f of g of x, you're going to multiply these two things together. So 3x minus 1 times x squared plus 1. Now you need to FOIL. 3x cubed plus 3x minus x squared minus 1. We got any like terms? I'm sure we do. 3x cubed minus, no we don't. We just have to write it in standard form. F divided by g. 3x minus 1 over x squared plus 1. That's all you can do. You can't factor anything. You can't really cancel anything, so you're finished. f of g means you're going to take f of x, and everywhere you see x, you're not going to write x anymore. You're going to write g. So that's getting plugged in for x. So now it's x squared plus 1, which you can distribute 3x squared plus 3 minus 1, and then you can simplify 3x squared plus 2. What if we go the other way? That means this is like saying g of f of x, just different notation. So take f and plug it into g. So now I have, instead of x squared plus 1, I'm going to put 3x minus 1 squared plus 1. And I want to FOIL that out. So I'm going to FOIL that out. That'd be 3x minus 1 and 3x minus 1. FOIL, 9x squared minus 3x plus 1, still plus 1. 9x squared minus 6x plus 2. Okay. Find the domain and range. You can graph this, but I can tell you what it's going to look like. I know that it's a radical that has gone right 3 and up 1, so it looks like this. It's not a pen, be a pen. It looks like that. So the domain is the x's. The smallest x here is 3, and it goes forever to the right, so 3 to infinity. You can't count to infinity, so use a parentheses, but you can use 3, so that's a bracket. And the range is 1 to infinity. The smallest y value is 1. The biggest y value is infinity. I can do this one as well because I know it's going to go down 5. So it looks like this. Cube roots all look the same. It's a cube root. That's not really horizontal, is it? It looks like this. But since it goes forever left and right, the domain is negative infinity to infinity, and it goes forever up and down. The range is negative infinity to infinity as well. So domain is a set of x's, and the range is a set of y's. Last thing, we're going to solve. So to undo a square root, we square both sides. Now I have 25 equals a plus 1. That means that a is 24. Subtract 1. Go back and check it. 24 plus 1 is 25. The square root is 5. Cool. Square both sides. X minus 1 equals x squared plus 3x. Collect like terms, so subtract x and add 1. Now you have to factor that, which will end up being x plus 1 times x plus 1. You can do the split the middle part, which means x equals negative 1. So if this whole thing equals 0 over and over again, then that means x is negative 1. But this doesn't actually work, because if you try and plug negative 1 in, negative 1 minus 1 is negative 2, and the square root of negative 2 is imaginary. So this is called an extraneous solution. There are no solutions that actually work to this problem. It's an extraneous solution. So there are no solutions. Isolate the root, so subtract 7. 2 equals the cube root of x. Then undo that by cubing both sides. On the left side, 2 cubed is 8. On the right side, you have x. So if I check that, the cube root of 8 is 2. 2 plus 7 is 9. Cool. Isolate the exponent. 3x to the 3 halves. Add 6 to both sides. Divide 3. Now, to undo a 3 halves root, you need to take the reciprocal root of both sides, so 2/3. The cube root of 8 is 2, and if you square 2, you get 4, so x equals 4. I'm going to plug that in my calculator. That's not my calculator. And we'll see if it comes out right. So 3x is 4 to the 3 halves minus 6. I should get 18. I got 18. Cool. I know I did it right. Square both sides. Whoa. Square both sides. You need to FOIL on the left side. That's the easiest way to miss this problem. On the right side, you have x plus 5. So FOIL, x squared plus 3x plus 9. X squared plus 6x plus 9. And now I'm going to collect like terms. So if I subtract x, I got 5x. And if I subtract 5, I got 4. Now I can factor that. The numbers that multiply to 5 and multiply to 4 are 4 and 1, which means x equals negative 4 or x equals negative 1. Or does it? You got to check it. If you plug negative 4 in, on the left side, you're going to get a negative, and the square root of a number is always going to be a positive. So that's extraneous, but this works. Negative 1 plus 3 is 2, and negative 1 plus 5 is 4. The square root of 4 is 2. Cool. One more, square both sides. X squared equals 2x minus 1. Collect like terms. factor what multiplies to 1 and adds to negative 2. X minus 1, x minus 1. So x equals 1, or does it? 1 equals the square root. Yep, it does. X equals 1. Cool. That's it. That's the whole second quarter, and it only took us 20 minutes. So good luck on your finals, and have a good break.